in this video, we're going to look at how to prove the T formulas. Okay, the T formulas, this thing. That's on your reference sheet. Okay, it offers you a way to solve trigonometric equations that you will see later. Now, I'm going to draw, let's look at this right angle triangle over here. We're going to let T equals to tangent of A on 2. That means if this angle is A over 2, tangent of A on 2 is T, okay, and tangent of A on 2 is equal to T, which is same as T on 1, which means opposite side is T, sorry. And then the adjacent side is 1. That means the, let me change the color. Opposite side is T, the adjacent side is 1, and the hypotenuse is square root of T squared plus 1. Okay, so we know that is true. Now that means I can I can rewrite the sine and cosine functions. Okay, sine A on 2 must be opposite over hypotenuse, and cosine of A on 2 must be adjacent over hypotenuse. Okay, now let's take a look at the rest of it. Then we're saying that if this is true, then sine A, cosine A, and tangent A are equals to those things. Notice the difference here. This is A on 2. When it gets to here, we have actually increased the magnitude of the angle by 2. Okay, so this is actually a double angle thing. Double angle, because we have increased the magnitude of angle by 2. We went from A over 2 to A. So therefore, I know that I probably have to look at a double angle formula. According, I've rewritten the double angle formula over here. If you think about double angle formula, tangent to theta equals to 2 tangent theta over 1 minus tangent square theta. That means tangent of A is equals to 2 times by tangent of A on 2, or over 1 minus tangent squared of A on 2. Alright, because if you think about it, this is double this, and this A is double of A on 2. Okay, now what was A on 2? A on 2 was T. So this is the same as 2T over 1 minus tangent of A on 2 is T squared. So this is the first thing, which is 2T on 1 minus T squared. That's the first thing. Oh, that's the last one on here. Okay, that's the last one over here. Right there. Okay, now same thing, I can play around with sine and cosine. Let's play around with sine. So if we have sine, let's take a look at sine. What is sine 2 theta? Sine 2 theta is 2 sine theta cosine theta, which means that sine of A must be 2 sine of A on 2 times by cosine of A on 2. Again, the relationship between 2 theta and theta over here, and there is the same as the relationship between A and A on 2 and A on 2 over here. Okay, it's double. So that means this is the same as 2 times by, what was A on 2 again? A on 2 was this thing. Okay, so T over square root of T squared plus 1 times by cosine of A on 2 is this thing. 1 over square root of T squared plus 1, which is the same as 2T over T squared plus 1, which is the first one over here. Okay, let me redraw that a little bit. Same thing as this. Okay, this is the same. Okay, now let's look at the last one. No surprise, it's exactly the same thing as what we've been doing before. We're now looking at cosine of 2 theta. We know that cosine of 2 theta is 1 minus 2 sine squared theta. Okay, so that means cosine of, I just randomly picked one out of the 3 identities. You can pick whichever one, you end up with the same result. Okay, so anyway, from there, that means cosine of A equals to 1 minus 2 sine squared of A on 2. Again, observe that 2 theta and theta, here is A and A on 2, it just means it's double. Alright, so this means that this is the same as 1 minus 2 times by, what is sine A squared? Sine A squared is T over square root of T squared plus 1. Okay, so once we get to there, then we can say that, okay, this is the same as 1 minus 2 T squared all over T squared plus 1. Same common denominator, that is T squared plus 1 minus 2 T squared all over 1 T squared plus 1. Okay, so this is the same as T squared minus 2T squared is negative T squared plus 1 all over T t squared plus 1, which is same as 1 minus t squared over 1 plus t squared. Okay, the last one is the last one over here. Okay, these two are the same. Let's do that all the way here. Okay, so there we have proven this identity is true. Okay, we have shown that this is true. So if we let t to be tangent theta theta on 2, then I know to find sine theta, cosine theta, tangent theta, we can use this algebraic expression. We'll talk about how to apply this in the next video.